Hey everybody, in this video we're going to be solving right triangles for unknown angles. If you want to follow along, the links to the companion worksheet are in the description below. One thing to point out is that we will be using calculators to find approximate answers. And one thing to remember is that you want to be sure of what mode your calculator is in. Because when you're using sine and cosine and tangent, the number one mistake is people being in the wrong mode. So if I click on mode here, I want to be sure what unit I'm going to be in. Now I'm going to be using degrees for this entire video, so all of my calculators are in degree mode. But if you're following along with your calculator and get a different answer than what I'm getting, it's probably because your calculator's not in the same mode. Now if you have a scientific calculator, what you want to be looking for is around the edge of the screen, you want to be looking for a letter D or DEG. And that means that you are in degree mode. If you see something like an R or an RAD around the edge of your screen, that means that you're in radian mode, and that's what the calculator will assume you want when you want it to give you an angle. So just be aware of that. So here we have this right triangle, and we know these three sides. It's a 6, 8, 10. And so we want to know what is A and what is C. Well, if we want to figure out what angle C is, we can look at this and say, well, 6 is the opposite and 10 is the hypotenuse. So we could write sine of C equals 6 over 10. The problem is, like this, doesn't help us because we have no angle to plug in. So what we have to do is we have to say, well, wait a minute. I can't take sine of C, can't take take a sine of an angle I don't know. And so here's where we use the inverse. Okay? So instead of taking sine on this side, what I'm going to do is I'm going to take arc sine of this side. And this is the inverse of sine. And the difference is with sine, you plug in an angle, get a ratio. With arc sine, you plug in a ratio and get an angle. Now on your calculator, arc sine can be found right next to the sine button. It's written right here, sine like that. Now I'm always going to write it as arc sine because too many people, when they see that, they think they mean sine to the negative first. That's not what that means. So if I type in arc sine of 6 over 10, I'm going to get 36.870 degrees. And so if I want angle A, I can do the same thing with angle A. Sine of A equals 8 over 10. So that means angle A is going to equal arc sine of 8 over 10. And this is perfectly fine as an exact answer. But if your teacher wants an approximate answer, we can type that into our calculator. Arc sine of 8 over 10. And that gives us 53.13 degrees. So on the next example, here we're looking at the Big Ben clock tower, and we know it's 80 feet tall and we're standing 80 radical 3 feet away. So the question is, what is the angle? Well, we know that this is the opposite to this, and we know that this is the adjacent side because Big Ben stands at a right angle to the ground. So that means tangent of x is going to equal 80 over 80 radical 3. Now I'm going to leave radical 3 in the denominator because it's not going to be involved in our final answer. We're just going to type it into our calculator. So we have arc tangent of 80 over 80 radical 3. And if you want to, you can save yourself a little bit of time and cancel out the 80s. So we have 1 over radical 3. So that would be a more exact, precise answer. If we're looking for an approximate answer, we'd have 1 over radical 3. We plug that into arctan, and we get 30 degrees. Now in the next problem, here we have an isosceles triangle, and we want to find the unknown angles. Now, it seems out of place because this video is all about right triangles. And so the way we solve this is we say, well, let's draw down the altitude. And because we draw down the altitude, because we say it's the altitude, it makes a right angle right here. Now, because it's an isosceles triangle, it's going to break up this side into lengths of 2 and 2. And so we've got two identical right triangles, and they have hypotenuses of 5. And with these unknown angles, they have adjacent sides of 2. So let's call this theta. So that means cosine of theta equals 2 over 5. So if I want theta, that means that's arc cosine of 2 over 5. So when I type that into my calculator, I get for theta 66.422 degrees. And so that's this angle here for angle B and for angle C. And for angle A, if I need to find that, that's going to be 180 minus 66.422 minus 66.422. So I subtract that twice from 180, and I get 47.156 degrees for angle A. Now for the next one, it says right here we're looking up at a screen that's 30 feet tall, and it's 50 feet up in the air. Now we're standing back 100 feet from the bottom of the screen, and we want to know what is our viewing angle of the screen. Now when we say viewing angle, we mean this. We mean theta. That's our viewing angle. Now this one we're going to deal with more specifically in the next video, but for right now we can say x is really 100. Now what we've got is we've got two right triangles going on here. The first one, this side is 100, and that includes both the screen and the wall. And so here our angle is theta plus phi. That's phi right there. Now our other right triangle is shorter, that's 100, and that includes just the wall up to the bottom of the screen, and this is phi. Now what we want is theta. So what we're going to do is we're going to find this angle and this angle. Now for both triangles we know the opposite side and we know the adjacent side. So we can write this as tangent of theta plus phi, and that equals 80 over 100. And for simplicity's sake, I'll simplify that to 4/5. And over here, I've got tangent of phi, and that equals 50 over 100, or just more simply, 1/2. Now, since both these angles are unknown, we're going to rewrite it as theta plus phi, and that equals arctan of 4/5. And over here, phi is arctan of 1/2. Now, what do I want? I just want theta. So this quantity represents both theta and phi, and this represents just phi by itself. So what I've found is I've found this angle, and I've found this angle. So to find theta by itself, what I have to do is subtract them. So theta is going to equal arctan of 4 over 5 minus arctan of 1/2. That's my exact answer. And I can use my calculator to give me an approximate answer. So arctan of 4/5 minus arctan of 1/2. And so approximately 12.095 degrees. And that's when we have it at 100 feet. Now in the next video we'll talk about what position gives us the optimal angle, but we're not going to talk about that. You can watch the next video to see that. So here, number 5 asks, why is the value of arcsine of 1.5 impossible? Now we can confirm that that's impossible. Take arcsine of 1.5, and it gives me an error domain. But the question is why? Why is that so? Well, if we think about it, this represents a ratio. And what we want is we want arcsine to give us an angle. So let me write this out. Arcsine of 3/2 equals theta. And if I were to rewrite this more conventionally, as we're used to, 3/2 equals sine of theta. So with sine, we plug in an angle, we get a ratio. With arcsine, we plug in a ratio, we get an angle. Now this is still problematic. It just came from that, I just rewrote it. But this helps us to see why it's problematic. With sine is the ratio of the opposite side over the hypotenuse. Now in this case, we're saying that 3 is the opposite side and 2 is the hypotenuse. Well, that's impossible. In every right triangle, the hypotenuse, by definition, is always the longest side. So what we're trying to say is we're trying to say that there is some triangle out there that has a length of 2 here and a length of 3 here. Can't happen. And so that's why arcsine of 1.5 is impossible. We're trying to create an impossible triangle. Now for the last one, we want to find the value of arc cosecant of 4 on the calculator. Okay, we don't have arc cosecant. All we have is arcsine right there, arc cosine, and arc tangent. So how do we do this? Well, let's think about this. Theta equals arc cosecant of 4. Now this is our angle that we want, and this is our ratio. Now let's say we rewrite this. The cosecant ratio at this point is 4. Well, cosecant is related to sine. And so if cosecant is 4, then sine is 1 over 4. Now theta hasn't changed. And that's the key thing. The ratio has changed, but the angle has not. So I can find theta by taking arc sine of 1/4. And that's the same thing as arc cosecant of 4. So that's going to give me an approximate value, arc sine of 1/4. And so that's 14.478 degrees. Thanks for watching. If you liked the video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. Remember, the best way to understand something is to do it.